similar to this. So we're just going to crank through this. For this one, it says find all possible functions with the given derivative. So this is, we're starting off with f prime, and I'm just going to write it bigger up here, and then we're going to work backwards, okay? So we have f prime of x is equal to 24x squared plus 6x, right, minus 9. And then what they want us to do is kind of work backwards. They want us to figure out what f of x would be. Well, this is going to be x cubed, right?
Yeah.
So I had to multiply, I had to multiply 3 by some number to get 24, right? Because if you reverse the power rule, and somebody said it was 8, right? So this is 8x cubed. Now you can just double check it. In fact, when we start chapter 5, I'll show you a formal process. But right now, these are simple enough we could guess and check. So that's that one. So now for the next one, because this is x to the first, that term had to have been x squared. So 2 times some number had to equal 6, so it'd be 3, right?
Yes.
So if I took the derivative of that, that would work. And then for 9, I've got a minus 9 here, but that was really, this is like x to the 0. So this needed to be x, and so this would be 9. And then there is a possibility that I had a constant, right? I don't know what the constant is, but when you take the derivative of a constant, you can think of it in terms of like there's a plus 0 on the end. So here we put plus c. So 8x cubed, 3x squared, minus 9x, plus c, this one, right? Yep.
I don't know, I can't see that far.
Does that make sense?
Yes.
All right, did anybody have any questions on how to do that?
No.
All right, let's just crank through to the next one. So now,
Just trying to stay alive.
just trying to stay alive. It says find all the possible functions. So they give us f prime of x. All right. Now for this, I want you guys to remember. So again, we're trying to find f of x. Right. Now remember that if I have some constant e to cx, right? And I try to differentiate that with respect to x, it's like big C, well, maybe we'll just
Big
do
B.
the x.
Big B.
If I have like 3x, then it'd be 3c e to the x, e to the 3x, and then we tack on the derivative and stuff, right? So what is this?
It's B.
Well, yeah, so we know that the derivative of e to the x is just e to the x. But somehow I have to get this, because this is 5x, that means the 5 is there, right? So I know that I'm going to have e to the 5x. Now, if you think that through and you take the derivative of that, it's e to the 5x. Let me write it in terms of u. Maybe that would help out. The derivative of e to the u is going to be e to the u times u prime. So this 5 is actually the derivative of this. So I think my answer is just e to the x, but again, we have the potential to have a constant over here, and we don't know what it is, so when you take the derivative of a constant, it just goes to 0. So you've got to think of f prime as whatever they give you plus 0, and then remember that the derivative of a constant is 0. Does that make sense? And so somebody said, is it A? And the answer is yes.
Ooh.
Does that make sense?
We won.
Any questions about that?
No.
All right, good. Let's do problem number 3. Man, we are flying. All right, so now for this one, oh, you guys, I'm gonna do something really awesome for you guys today. So does that f prime? We said that f prime of x is equal to x squared plus 5, and it passes through the point 3 comma 51. I'm writing it big so you guys can see it in the back of the room. And it says, find the function that goes through these points. So this process is just like problems 1 and 2. This has got to be x to the third. Well, what do I multiply 3 by to get 1? This is a 1 here.
1/3.
1/3, right? So this has got to be like that, right? Because when I take the derivative, the 3 comes to the front, and I divide by 3, and I get x squared. Is that true?
Yes.
Okay.
Yeah.
So now for the next one, this has got to be 5x, right? Because when I take the derivative of 5x, what do I get? 5. And then there's a possibility that I have the point C.
Yeah.
Does that make sense?
Yes.
All right. So now this is x, and this is f of x. So if I take this equation, I say 51 is equal to 3 cubed over 3 plus 5 times 3 plus c. So what I've done is I've gone in here wherever there is an x, I've plugged in 3. And wherever there was an f of x, right, I've plugged in 51. And I did that because we want to know what c is. Does that make sense?
Yeah.
All right, so let's look at this. So I've got 51, so 3 cubed is 27 divided by 3 is 9, right? So I've got 9 plus 15 plus c. Is that right? I did that kind of quick. 27 divided by 3 is 9. So then this is 24, right?
Yeah.
So I've got 51 minus 24, which is, huh?
27.
Is it 27? So I've got 27 is equal to c, right? If I go through and do the algebra.
Mm-hmm.
You guys know how to do that. I don't need to write out every step, do I?
No.
Okay. So, hey, that's one of our options, right? What option is it?
I can't see B.
Yeah, but
B. Whoops, I got to put my...
wait, what is the 27 justifying?
That's the C. So my real f of x, this f of x, if I rewrite it, it's f of x is equal to x cubed over 3 plus 5x plus 27. Because we solved for C. Does that make sense?
Yeah.
You guys feel good about that?
Yeah.
That's good because that's, these are some of those problems that are on the multiple choice portion of the AP exam, and you guys have a leg up on it, right? And we're doing them rather quickly. So let's move on to the next one. All right, so now this one, it says use the concavity test to find the intervals of the graph where it's concave up. So I have y prime equals negative 3x squared plus 18x.
Is it Y or Y prime?
It's just y.
Okay.
So now concave up and concavity test means I need y double prime, right? Because it's the second derivative test.
Yes. Yeah.
All right, so y prime is negative 6x plus 18, right?
Mm-hmm.
Is that right? Okay, so then y double prime is just negative 6.
What? No?
Yeah.
Yeah.
Yeah?
I'm just kidding. I put another square. That's my bad.
Now, here's the tricky one, okay? When is this equal to 0?
Never.
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 All right, so there's really no critical point. So now we need to think in terms of the graph. If y double prime is equal to negative 6, this is what it will look like. Y double prime equals negative 6.
Crazy.
What is the value for y double prime? Always.
Negative 6.
Yeah, it's negative, right? So y double prime will always be negative.
So down.
So for the whole thing, it's concave down, and they want to know when it's concave up.
Oh.
Never. It will never be concave up.
Never ever.
And
Never leave you alone.
okay, I'm recording. Now, when you think about this, if you look at y, that makes sense because it's a parabola with the leading coefficient that's negative. So this is going to look something like this, right? It's going to look like something like that.
Oh, yeah.
So it's always going to be concave down. It's always going to curl down. Okay? Any questions?
No.
All right, good. You guys are doing well. Okay, number 5, points of inflection. Points of inflection occur when y double prime equals 0. They've given us that y equals x cubed minus 12x squared plus 2x plus 15. Y prime is equal to 3x squared minus 24 plus 2. Y double prime is equal to 6x minus 24. Is that right?
Yeah.
So the point of inflection occurs when this equals 0. So I'm going to say 0 equals, now if I factor out a 6, I get x minus 4. When I divide both sides by 6, I get 0 equals x minus 4, or x equals 4. My point of inflection occurs when x equals 4. But that's not the point, right? I got to figure out the y value when x equals 4. Of what? Y double prime, y prime, or y? Y. So I got to come in here and I'm going to say y equals 4 cubed minus 12 times 4 squared plus 2 times 4 plus 15. Okay? And I'm feeling a little lazy today. We're going to do that on the calculator. All right? So I should have wrote that down. So what was it? It was 4 cubed, yep.
Minus 12 times 4 squared plus 2 times 4 plus 15.
Did I do that right? Now you could put stuff in parentheses, but your calculator follows the order of operation, so I think we'll be okay. So it's negative 105.
Please excuse my dad.
Is that one of our options?
Yeah.
Negative 105. So this y of 4 then equals negative 105, which means the point 4 comma negative 105 is on the line.
Boom.
Boom. Whoops.
Well, bam.
Boom. With
Is
the
that right?
bacon sizzle.
Wha-bam with the bacon sizzle.
Yep.
Forgot the wabam.
All right. Any questions on that?
No.
All right. So now look at this. It says the graph below shows the first and second derivatives of the function y. Select the graph of f that passes through point P. Okay? So now this is not that hard. F prime is x squared plus c, where c is right here, right?
Yeah.
Yeah.
Now notice that here we have positive, so it's increasing up to this point, and it's increasing, whoops, it's increasing from this point here, and then because it's negative down here, right, that's decreasing. So we're going to have a function that increases, decreases, and then increases.
Got it.
Right? Which, by the way, it's some sort of variation of x cubed, right? Which would make sense. Everything lines up, right?
Yes.
All right, good. So, and right here on the y-axis, we're going to have a min or a max, right? But since it goes from increasing to decreasing,
And then
well, it goes up and then down. So that's actually a max
What?
on the y-axis,
what?
right?
Oh,
Because the function goes up and then it comes down,
I thought you were talking about down.
right? So it's increasing here and then it decreases.
So is there a maximum?
Now, yeah, so now here's the other thing too. Negative f double prime. So if we look at f double prime, Well, that's just some variation of x, right? It's a straight line, it's a linear function. And so from here, it's concave down, and then from here, it's concave up. So we've got concave down and then concave up. And the point of inflection, here's the weird thing, the point of inflection occurs at the origin. Okay. Oh, you know what? I am sorry. I made a mistake here. This is where we have our max, and then we have a min right here. Because those are the points. So think of the number line like this. We have these points here. It's increasing, decreasing, increasing. And then for this line, right at the origin, we have concave down and concave up. And it has to pass through the point C. So what we're looking for, okay, do you guys see that? Because I got to clear the screen.
Yes.
All right. So I'm going to sketch this so before we look at our options. It's going to pass through this point here, which is the point of inflection, right?
Yeah.
So it's going to kind of do one of these deals. That's what it should look like.
Okay.
Does that make sense?
Yes.
All right. So now that we know that, let's clear it out. Now let's look at our options.
D.
Little D.
It's D, right?
Woo. Yeah.
Letter D.
Good job.
Thank you.
And we didn't know what the function was. That was all based on the graph. That's why I showed you guys yesterday how to do the graphs.
Yes.
Okay? All right, let's do the next one. Okay, this one was a tough one. I'm going to rewrite this. This is the first test, second test, right? And so first test is for f prime. And so what we want to do is we want to look at f prime. So when these are the critical points, 2, -2, 0, okay? And so then the other thing is that we're going to have f double prime here. And we got a couple of points that are of interest to us. I only see 2, -2, so we're gonna look at. Oops, I didn't want that color. We're gonna look at these 3 points where this is -2, this is 0, and this is 2. And then we're also going to look at f of x, because they give us some information about f of x, okay? And then we're going to plot the graph based on this. All right, so the first thing that it says to us, when x is less than 2, what is y prime?
I can't see.
So we're going to look at this line here first. Well, if you can't see it in the back, it says when x is less than 2, y prime is greater than 0. What does that mean?
You tell us. I have no
Positive.
idea.
It's positive. So less than 2, y prime is positive. So this is positive, this is positive, this is positive, I think. And we might, if they give us another clue, it says y double prime is less than 0. So what's y double prime?
Negative.
Negative. Okay? Negative. So now here I'm going to put negative, negative, negative. Now we may need to erase some of these things as we go through the list, okay? So now we're kind of done with that list. Moving on to the next line. When x is 2, -2, what is y? 10. So here we've got the point, well let me just, here we've got the point -2, 10. That's f of x, right? But it tells us that y prime equals 0 at 2, right? So that means this is a critical point right there. And then it says that y double prime is less than 0 at -2. Well, that doesn't contradict what I have written on the board, right? But it does tell us that it's not a critical point for y prime, right? Or y double prime. So this is not a critical point at all. So we're done with that information. Next, from -2 to 0, y prime, from -2 to 0, y prime is less than 0. From -2 to 0,
So the middle plus mark is a negative.
so this is a negative, okay? And that's okay. Mr. Adams is just filling this out. And it says y double prime is negative. Well, did that change anything?
No.
No. Then at 0, f of x, so we're done with this. At 0, f of x is -6. So that's a point on the line. Is that a critical point? No. Well, let's see. It says y prime is less than 0, but y double prime is equal to 0. So this is a critical point here for y double prime. Now what does that tell us? That tells us at here, this is a min or a max, possibly, because it's a critical point of f prime. When we have a critical point of f double prime, that means that it's a point of inflection, right? Because y double prime is 0. So we're done with that information. You guys with me so far? Am I going too fast?
Good.
Okay. So now 0 to 2, y prime is less than 0. So from here to here, y prime is less than 0. From 0 to 2.
So the third plus mark is negative.
Yeah, so this needs to be marked as negative. Right?
It's just a whole bunch of
Is that right?
Yeah.
Okay, we're doing good so far. And y double prime is positive,
So then the third plus mark is a plus sign.
right? Is that right so far?
Plus. Yep.
That's all the information we've got from that one. Then it tells us that when x equals 2, right? When x equals 2,
Yeah.
then we've got y equals -22. Is that right so far?
Yeah.
Okay. So then, is there any other information on that? Y prime is 0 when x equals 2. So that means that this is a critical point here. So that's a possible min or max. We're not sure yet. Okay?
Wait, you didn't do the other one.
It says that y is greater than 0.
Oh, y double prime is greater than 0?
Yeah.
We already have that listed, right?
Yeah.
Okay, that means it's positive. So now we need x greater than 2. Well, it says that y prime is greater than 0, so we have a positive here. Okay? And then it says y double prime is greater than 0, so we have a positive here. All right. Now we got to graph this somehow. Now I'm gonna sketch it real quick and then we'll choose. Okay? Let me do a little bit better job of drawing my thing. I've got this and this. We have 3 points of interest. I've got -210. We'll say it's about right there. That's a possible min or max. Well, it goes from positive to negative. That means it's increasing to decreasing, so I've got a max here, right? No min. And then I've got a point of inflection on 0, -6, so about right here as a point of inflection. It's curl down from here, curl up from here. Is that right?
Yes.
Then at 2, -22, I go from decreasing to increasing. Well, that's a minimum, isn't it? So way down here at 1, 2, way down here at -22, I've got a min, which means it goes like that. So my graph should look something like this. Right? Does that make sense? Does everybody understand what we've done?
Yes.
Alright, so I'm going to clear off all this messy stuff that I've written down, and let's find that graph.
Let's do it.
It looks like B to me.
Yeah.
Letter B.
Not bad, not too shabby. Our last, any questions before we do our last problem?
No.
No? Okay. Alright, solve this problem. Oh man, that looks complicated. Whoa. Select the appropriate graph of the twice differentiable function f of x. That means it has two derivatives. And it gives us the f prime, f double prime, and now they write it in a table. And it tells us what points they pass through, right? So right here, it goes from positive or increasing to decreasing. So this is a max at the square root of 2. Here it goes from 0, it goes from decreasing to increasing, so we've got a min, and then here we've got a max. Alright, so I'm going to sketch it over here to the side. So at negative root 2, does anybody know off the top of their head what root 2 is approximately as a decimal? Good. Good. It's 1.414. Good. And sometimes, you should know that from your trig functions, right? Because root 2 over 2 is 0.707, and if you multiply that, you guys haven't memorized that? You should. What is the square root of 3?
Oh, 1.7 something?
1.73. Very good. You guys should memorize that. Oh, if you can see the look in her eye. So now I've got a min and a max, so a point on the line is negative 2, 1. So at negative 2, 1, I have a max. This goes a lot quicker because they're giving us information. At 0, 0, I'm in the origin. I have a minimum. Are you guys watching this?
Yes.
And then at square root 2, at 2, 1, I have a max. Now, the only thing we need is concavity. We have 2 points of inflection, which is root 6 over 3. Root 6, well, that's not a very common one.
6d6.
Huh? But it's less than 1.41, right? So what is 2 squared? 4, right?
4.
What is 3 squared?
9.
9, right? So we know that it's between 2 and 3, right? The square root of 6 is between 2 and 3, but then we're going to divide it by 3. 2 divided by 3 is 0.6. 3 divided by 3 is 1. So it's between 0.6 and 1.
Point.
Do it on your calculator. The square root of 6 divided by 3.
Wait, what?
0.82.
Of 6
Calling it.
divided by 3. 0.8. It's like 0.82. 6.
Oh sure, I did all the heavy lifting. You just picked out a number in between. So yeah, so it's like 0.8. So anyways, right here, we've got the square root of 6 over 3. She's so proud of herself. Then I said I did the heavy lifting. She was like,
No, I said I'm a prodigy.
yes, you are. So here are the zeros, and so it's concave down to here, concave up here, concave down. All right. So it's concave down from here to here, concave up from here to here, concave down. And where do those points of inflection occur? At 5 over 9, which is about 1/2. So it's about here and here. So now if I go to graph this thing, it's going to look like this. All right? Does that make sense?
Yes.
So we just need a graph that looks like that. Is it A?
No, it's
No.
B.
Let's scroll down.
It's B.
B looks pretty good. Yeah.
Letter B.
It's the only